So we're given a starting wavelength of 520 nanometers. This is starting off through air. So that's important because the index of refraction of air, I'm going to just use as 1. I'm just going to pretend air is a vacuum, just to keep things a bit simpler. The angle of incidence is 50 degrees. Now on the refraction side, or the transmitted side, the angle of refraction is 35 degrees. Okay, so we have to find out the new wavelength. We also don't exactly know the new index of refraction either. Okay, so we're going to be using Snell's law. Now, there's two versions of Snell's law. There's one where we use index of refractions, like this. And there's another version, I'll use a different color, where we use speeds. Oh, that is wrong. Let me try again. Okay, so two versions of Snell's law. Which one should we use when our goal is to find the wavelength? Well, I think it's probably best to choose the blue one because there is another relationship that relates speed and wavelength. That is v equals lambda f. Okay, so I can replace the speeds with lambda f's in there, and then hopefully eventually solve for lambda 2. So what's important to note is that the f value, the frequency, will be the same in both media. So that was one concept I tried to hit on during lesson 1, is that the frequency depends on the vibrating object that's creating the wave itself. However frequently it's vibrating, that's going to be the frequency of this wave. And just because the wave enters a new medium, it's not going to change the frequency with which that particle was vibrating. So the f's are the same on both sides of the equation, which allows them to cancel out. So then I can go ahead and rearrange this now for lambda 2. So that will end up being, so some cross multiplying and dividing will result in lambda 1 times sine of theta 2 over sine of theta 1. I'm going to do something I don't do too often, which is not convert my lambda to SI units. So this is 520 nanometers. I don't need to convert it because the rest of the equation are unitless, like sine of 35 degrees is unitless over sine of 50 degrees is unitless as well. So my final answer when I calculate this is just going to be in nanometers, which is fine to have an answer in nanometers. So I'm coming up with 389 nanometers. That would technically be to 2 sig figs because my angles have 2 sig figs. I probably should have just put 3 sig figs in the question, but oh well.